What if every thought you've ever had, every flicker of consciousness, wasn't just happening inside your brain, but was woven into the very fabric of the universe? This isn't science fiction. It's one of the most daring ideas to emerge from the crossroads of quantum physics and neuroscience, the theory that consciousness itself might be a fundamental force of nature, as intrinsic to reality as space or time. Picture this: the particles in your brain, the atoms in distant stars, all humming with the same mysterious spark of awareness, entangled across the cosmos. It sounds impossible, yet some of the brightest minds in science are seriously considering it. And today, we're diving into 30 theories that blur the line between mind and universe, each one more mind-bending than the last. Think about the last time you knew something deep in your gut without knowing how, or the eerie feeling that the universe is watching, responding, as if reality shifts just to meet your gaze. These aren't just quirks of perception, they might be clues to a truth far stranger, that consciousness doesn't arise from matter, but that matter arises from consciousness. From ancient Eastern philosophies to cutting-edge quantum experiments, the idea that the universe is alive, aware, and somehow thinking through us has haunted human curiosity for centuries. But now, science is catching up, and what we're discovering could rewrite everything we thought we knew about existence. So why does this matter? Because if even one of these theories is true, it changes everything. The boundaries between you and the cosmos dissolve. Death, meaning the nature of reality, all of it gets a radical new interpretation. Over the next 30 revelations, we'll explore how black holes might store memories, why quantum particles seem to choose their behavior when observed, and whether the entire universe could be a single, self-aware mind. Buckle up, this isn't just a journey through science, it's a voyage into the deepest mystery of all. What if the universe knows it exists through you? Imagine standing at the edge of the ocean, feeling the vastness stretch beyond the horizon, then realizing the ocean might be feeling you back. That's the essence of our first theory. The universe isn't just a cold, empty stage for life to play out on. It might be alive, aware, and conscious in ways we're only beginning to grasp. This isn't just poetic speculation. Philosophers like Alfred North Whitehead and modern panpsychists argue that consciousness isn't something that emerges from complex systems like brains, it's fundamental, woven into the fabric of reality itself. Even atoms, they suggest, might carry a whisper of subjective experience. Now, hold that thought and consider quantum mechanics. Particles at the subatomic level don't behave like tiny billiard balls. They exist in fuzzy superpositions, multiple states at once, until someone observes them. Then, as if by magic, they choose a single state. The famous double-slit experiment shows this eerily well. Particles act like waves when no one's looking, but snap into particle form the moment they're measured. Nobel laureate Eugene Wigner took this further, proposing that consciousness itself might collapse these probabilities into reality. In other words, the universe might not have a definite state until a mind interacts with it. But here's where it gets wild. If consciousness is fundamental, then the universe isn't just hosting minds, it is a mind. Think of it like this. Your brain is made of neurons firing in complex patterns, creating your thoughts. What if galaxies, black holes, and quantum fields are the neurons of a cosmic brain? Some physicists, like Sir Roger Penrose, speculate that quantum processes in microtubules within brain cells might bridge physics and consciousness. Scale that up, and the universe itself could be engaged in one endless, self-reflective thought. Ancient traditions have hinted at this for millennia. Hindu philosophy describes Brahman as the universal consciousness underlying reality. Indigenous cosmologies often speak of the world as a living, sentient being. Even Western thinkers like Spinoza argued that God and nature were one, a single, thinking substance. Today, scientists like Giulio Tononi's integrated information theory suggest that any system with enough interconnected complexity, whether a brain or a galaxy cluster, might harbor some form of experience. Skeptics, of course, argue this is metaphysics dressed as science, but the math keeps nudging us toward strange possibilities. If the universe is conscious, it would explain why the laws of physics seem improbably fine-tuned for life. Maybe the cosmos isn't accidentally hospitable, maybe it's intentionally unfolding, aware of its own existence. That would mean every star, every atom, and every one of us is part of something far grander, a universe not just existing but witnessing itself. And if that's true, the next question is even more haunting. What is it trying to see? What if your thoughts aren't completely your own? What if, on some fundamental level, every conscious experience in the universe is subtly linked, like invisible threads connecting minds across space and time? This brings us to our second staggering theory, where quantum entanglement isn't just about particles, but about awareness itself. Take the Einstein-Podolsky-Rosen paradox, one of the most baffling experiments in physics. When two quantum particles become entangled, they share a mysterious bond. Change the state of one, no matter how far apart they are, and the other instantly responds as if distance means nothing. Einstein called this spooky action at a distance because it defies classical physics. But what if this spookiness isn't limited to particles? What if entangled particles are just the tip of the iceberg, hinting at a deeper layer where minds influence each other across the cosmos? Consider the work of physicist David Bohm, who proposed that reality is an unbroken whole, a cosmic hologram where every part contains the whole. In this view, separation is an illusion. Your consciousness and mine might seem distinct, but at the quantum level, they could be as interconnected as those entangled particles. Some researchers speculate that shared emotions, collective intuition, or even telepathic-like phenomena might arise from this quantum weave. Then there's the Global Consciousness Project, which monitors random number generators worldwide. Strangely, during major global events like the death of a public figure or a natural disaster, these devices show statistically improbable patterns, as if mass human focus bends randomness itself. Skeptics dismiss it as coincidence, but if entanglement extends to consciousness, it suggests that focused human attention might ripple through reality in ways we barely understand. Of course, critics argue this stretches quantum mechanics too far. Entanglement might link particles, but leaping to shared human experience, that's speculative. Yet pioneers like physicist Erwin Schrödinger once mused that consciousness could be the singular of which the plural is unknown. In other words, what we perceive as individual minds might actually be fractured reflections of one universal awareness. So where does that leave us? If entanglement binds not just atoms but minds, then every act of observation might be a cosmic collaboration. Your thoughts, your choices, even your sense of I, could be part of a vast, entangled network, a shared consciousness humming beneath the surface of reality. And if that's true, maybe the universe isn't just aware, maybe it's constantly listening. Have you ever stared at a hologram, watching it create a three-dimensional image from a flat surface, and wondered what if our entire universe works the same way? This brings us to the third theory, where reality itself might be nothing more than an incredibly detailed projection, a cosmic illusion painted onto the fabric of space-time. The holographic principle, first proposed by physicist Gerard T. Hooft and later expanded by Leonard Susskind, suggests that all the information in our three-dimensional universe, every star, every thought, every fleeting emotion, could be encoded on a two-dimensional surface at its boundary. Like a hologram where every fragment contains the whole image, the universe might store its deepest secrets on a distant, invisible plane. Now, here's where consciousness enters the picture. If the universe is a hologram, where does your mind fit in? Some theorists argue that our experience of reality, the vivid colors, the weight of emotions, even the passage of time, could be the result of this higher dimensional data being decoded by our brains. Think of it like a virtual reality headset, but instead of lenses, your neurons are interpreting quantum information from the edge of the cosmos. This isn't just wild speculation. Quantum information theory hints that the fundamental building blocks of reality might not be particles or waves, but bits of information, tiny yes or no answers to cosmic questions. Leonard Suskind's work on black holes adds another layer. When matter falls into a black hole, it doesn't vanish. Instead, its information gets smeared across the event horizon, the point of no return. This suggests that what we perceive as depth and solidity might just be a shadow play, with the true workings of reality unfolding on a distant, flat surface. If that's true, then consciousness could be part of this grand decoding process, an algorithm translating cosmic data into lived experience. Ancient mystics might have glimpsed this idea long ago. The concept of Maya in Hindu philosophy describes the world as an illusion, a shimmering veil over a deeper truth. Plato's allegory of the cave, where prisoners mistake shadows for reality, eerily echoes the holographic principle. Even modern neuroscientists note that our brains construct reality from electrical signals, much like a hologram reconstructs an image from scattered light. But the implications are staggering. If the universe is a hologram, then free will, identity, even the boundaries between you and the outside world might be part of the projection. Your sense of self could be a fleeting pattern in the cosmic data stream, a temporary eddy in an infinite sea of information. And if that's the case, the next question becomes unavoidable. Who or what is holding the projector? What if your brain isn't just a biological computer, but a quantum orchestra playing the symphony of consciousness at the smallest scales imaginable? This is the bold claim at the heart of orchestrated objective reduction, or ORCH, or a theory forged by anesthesiologist Stuart Hameroff and physicist Sir Roger Penrose. They propose that consciousness doesn't emerge from the firing of neurons alone, but from something far stranger, quantum vibrations happening inside tiny structures called microtubules deep within your brain cells. Picture microtubules as the skeletal scaffolding of neurons, tiny tubes that maintain cellular structure. But Hameroff and Penrose suggest they're more than just support beams. They might be quantum processors. According to ORCH, these microtubules harness quantum effects, where particles exist in multiple states simultaneously. When these quantum superpositions grow too large, they collapse in a process called objective reduction, and each collapse generates a moment of conscious experience. In other words, your stream of thoughts might be a cascade of these quantum events, like ripples in a pond of subatomic possibility. Penrose, a mathematician who worked with Stephen Hawking on black hole physics, brought a radical idea to the table. Consciousness could be linked to the very fabric of space-time. He argues that these quantum collapses aren't random, but orchestrated by deeper laws of physics, laws that might even bridge the gap between quantum mechanics and gravity. It's as if the universe itself is nudging these collapses into patterns that create awareness. Critics, of course, have sharp objections. Many neuroscientists argue the brain is too warm and noisy for delicate quantum states to survive. Decoherence, the tendency of quantum systems to get disrupted by their environment, should, in theory, shred these fragile processes instantly. Yet recent experiments hint that nature might have found a way. Some studies suggest that quantum effects could persist in biological systems longer than expected, with evidence of quantum coherence in photosynthesis and even in bird migration. And in 2018, researchers reported observing vibrations in microtubules that align with ORCH predictions, though the debate is far from settled. Hameroff takes it further, proposing that these quantum processes might explain near-death experiences. If consciousness is rooted in microtubules, their quantum states could persist briefly after clinical death, creating the vivid perceptions reported by some patients. It's a controversial idea, but it underscores the theory's ambition to place consciousness not just in the brain, but in the fundamental workings of reality. So where does this leave us? Or is either a groundbreaking revelation or a beautiful hypothesis undone by practical barriers, but it forces us to ask profound questions. If consciousness dances on the edge of quantum and classical worlds, could our minds be tapping into something cosmic? And if so, what else might be possible in that shimmering borderland between biology and physics? What if every choice you've ever made, every path taken or ignored, didn't just fade into the past, but splintered into countless parallel realities, each one hosting a different version of you? This is the spine-tingling premise of our fifth theory, where the multiverse isn't just a sci-fi trope, but a serious scientific possibility, one that could mean your consciousness isn't confined to a single timeline, but echoes across infinite worlds. The many worlds interpretation proposed by physicist Hugh Everett in the 1950s takes quantum superposition to its logical extreme. If a particle can exist in multiple states until observed, then every possible outcome must happen, just in separate, branching universes. That means somewhere out there, a version of you quit their job to become a painter, or missed the bus that led to their soulmate, or even died in a freak accident years ago. And just like the dizzying kaleidoscope of realities in everything, everywhere, all at once, each of these experiences their own subjective truth, convinced their world is the only one that's real. But here's where it gets even wilder. If consciousness is fundamental, as some of our earlier theories suggest, then these infinite selves aren't just doppelgangers, they might be entangled. Imagine your awareness as a river splitting into countless tributaries, each flowing through a different version of reality, yet somehow still connected at the quantum level. Physicist David Deutsch, a vocal proponent of the multiverse, argues that these parallel worlds aren't just hypothetical, they're mathematically inevitable, with interactions between them potentially explaining quantum interference patterns. Pop culture loves this idea, from sliding doors to Rick and Morty, but the science behind it is anything but fiction. In 2014, researchers proposed a testable multiverse model suggesting that neighboring universes could exert faint gravitational pulls on one another, a ghostly tug-of-war between realities. And if that's true, could fleeting déjà vu or unexplained intuitions be glimpses of other yous bleeding through? Critics, of course, call this untestable fantasy. Without evidence of these alternate worlds, the multiverse remains a tantalizing what-if. But supporters counter that the same math underpinning quantum mechanics, the most accurate scientific theory in history, demands these branches exist. The real shocker, if they're right, then death itself might be an illusion. In some universe, every version of you survives, thrives, or even evolves beyond what we'd recognize as human. So ask yourself this: if infinite consciousnesses share your name, your memories, even your essence, what does that make you? Are you the protagonist of your story, or just one thread in a tapestry of selves, each dreaming they're the center of the cosmos? The multiverse doesn't just stretch space and time. It stretches the very idea of identity to its breaking point. And somewhere, in some reality, another version of you is reading these words, wondering the exact same thing. What if time doesn't flow like a river, but flickers like a thought, a fleeting illusion stitched together by your mind? This radical idea reshapes our sixth theory, that time isn't a fixed backdrop to the universe, but a construct woven by consciousness itself. Think of the last time you lost track of hours in a gripping conversation, or how childhood summers felt endless while adult years blur together. These aren't just quirks of memory. They might be clues that time is more like a story your brain tells itself, a narrative woven from sensory fragments rather than an objective force. Physicist Carlo Rovelli's relational time theory strips away the myth of universal now. In his view, time isn't a rigid arrow but a web of relationships, events defined only by how they interact with other events. Without observers, the universe might not even keep time at all. Quantum gravity takes this further, suggesting that at the smallest scales, space-time dissolves into a foaming sea of uncertainty. There's no past or future here, just probabilities waiting to be collapsed, perhaps by conscious observation. Consider the famous delayed choice quantum experiment, where a particle's behavior seems to retroactively change based on future measurements. It's as if the universe waits for an observer to choose how events unfolded. If consciousness can reach backward to shape the past, then linear time might be a comforting fiction, a way for our minds to make sense of a reality that's far more fluid. Even Einstein admitted, the distinction between past, present, and future is only a stubbornly persistent illusion. Ancient wisdom whispers similar truths. Buddhist philosophy describes time as a mental projection, while indigenous cultures often view it as cyclical, a spiral of recurring patterns rather than a straight line. Modern neuroscience adds weight to this. When your brain processes sensory input, it constantly rewrites history, editing perceptions to create a seamless present. Your experience of now is actually a delayed reconstruction, like a director splicing film reels after the scenes were shot, but the implications are dizzying. If time is consciousness dependent, then the universe before life emerged might have existed in a timeless fog, only crystallizing into sequence when the first aware beings appeared. Black holes stretch this idea further near their event horizons. Time grinds to a halt from an outside perspective. For someone falling in, however, seconds pass normally. Which version is real? The answer might depend on who's looking. Skeptics argue this conflates perception with physics. Yet pioneers like Julian Barber propose that the entire universe could be a single, timeless now, with change arising from how consciousness navigates infinite static moments. Imagine flipping through a deck of cards, each card a frozen instant, but your mind creates the illusion of motion. If that's true, then your sense of time's passage isn't just a feeling, it's the universe waking up to itself, one conscious moment at a time. So the next time you check your watch, remember, those ticking hands might not be measuring reality, but reflecting the deepest mystery of all, how awareness turns chaos into story, and in doing so births time itself. We've chased the mystery of dark matter for decades, searching for invisible stuff that makes up 85% of the universe's mass, yet refuses to interact with light. But what if we've been asking the wrong question? Instead of just asking what dark matter is, consider this. What if it's alive, not in the way biology understands life, but as a vast, ancient network of non-biological consciousness humming silently in the cosmic dark? Fringe theorists like neurobiologist Todd Murphy and physicist Gregory Matloff have dared to suggest it. If consciousness is fundamental, as Panpsychism argues, why couldn't it exist in forms beyond brains? Dark matter's ghostly particles might not emit light, but they could still harbor some dim flicker of experience, a slow, cold awareness operating on timescales we can't fathom. Imagine a sentience so alien that a single thought takes millennia, its mind woven into the gravitational threads binding galaxies together. The math even offers eerie hints. Dark matter's distribution isn't random. It clumps in halos around galaxies like a cosmic nervous system. Some models suggest these halos could form intricate structures, filaments, and nodes resembling, of all things, the neural networks in a brain. Could the universe itself be thinking through dark matter's hidden architecture? Philosopher Alfred North Whitehead once proposed that reality is built from momentary drops of experience. Scale that up, and dark matter might be the universe's submerged mind, its thoughts too vast and slow for us to notice. Skeptics naturally dismiss this as poetic speculation. But consider neutrinos, particles once thought untouchable, now detectable with clever experiments. If dark matter consciousness exists, we might need entirely new tools to listen for it. Projects like the Action Dark Matter experiment already hunt for hypothetical particles. Could future devices search for patterns, even signals, in the data? The implications rewrite astrobiology. Alien intelligence might not scream across radio telescopes, but pulse imperceptibly in the dark matter currents between stars. Some theorists even propose that dark matter entities could manipulate gravity, subtly shaping galaxies like architects. If true, we might be living inside the artifact of an unfathomable mind. Of course, mainstream science remains unconvinced, yet history shows that today's heresy often becomes tomorrow's breakthrough. Whether dark matter harbors consciousness or not, the question forces us to confront a thrilling possibility. The universe's greatest mystery might also be its deepest sentience, an invisible giant dreaming in the dark, unaware that tiny beings like us are starting to suspect it's there. At the heart of quantum mechanics lies a bizarre truth: reality seems to change when we look at it. Not metaphorically, but literally. Particles exist in a haze of possibilities until measured, at which point they snap into concrete existence. This is the quantum observer effect, and it's not just about scientists tinkering with equipment. The deeper implication, consciousness itself, might be the sculptor of reality, chiseling the universe into shape simply by observing it. Take the infamous double-slit experiment, where particles like electrons are fired at a barrier with two slits. When no one watches, they act like waves, creating an interference pattern on the other side, as if each particle passes through both slits simultaneously. But the moment scientists place a detector to see which slit the electron takes, the particles behave like tiny bullets and the interference pattern vanishes. It's as if the electron knows it's being watched, changing its behavior to comply with our expectations. This phenomenon splits interpretations of quantum mechanics into two camps. The Copenhagen interpretation, championed by Niels Bohr, argues that the act of measurement collapses the wave function, the mathematical fog of probabilities, into a single outcome. Here, consciousness isn't necessarily special. Any interaction with a macroscopic device could trigger the collapse. But then there's the von Neumann-Wigner interpretation, which takes it further. Physicists like Eugene Wigner propose that consciousness itself is the trigger. Without an observer, a mind to perceive it, reality remains in a blurred superposition, unresolved. Wigner even imagined a paradox where a friend in a lab could exist in multiple states until he observed them, a thought experiment that makes even seasoned physicists uneasy. The implications are staggering. If consciousness holds such power, then the universe might not be a fixed stage but an interactive performance, its script written in real time by the act of observation. Some modern theorists push this further, suggesting that conscious observers don't just collapse possibilities, they create them. In this view, the Big Bang wasn't just an explosion of matter and energy, but the first conscious observation, a primal act of perception that set the entire cosmic story in motion. Skeptics, of course, counter with simpler explanations. The decoherence theory argues that interactions with the environment, not consciousness, cause the wave function to collapse. A stray photon or a gust of air could do the job. But even then, the question lingers: why does observation play any role in shaping reality? And why does quantum mechanics, the most accurate scientific theory ever devised, demand such a strange, mind-dependent framework, perhaps the most unsettling thought of all? If observation creates reality, then the universe before life arose might have existed in a hazy, unrealized state, a dream without a dreamer. Only when the first conscious beings emerged did the cosmos snap into focus, as if it had been waiting all along for someone to notice. So the next time you glance at the stars, consider this: they might not just be shining for you. In a very real sense, they might be shining because of you. Staring at a brain scan and a cosmic web simulation side by side, it's hard not to feel a jolt of recognition. The branching tendrils of neurons mirror the vast filaments of galaxies twisting, connecting, forming nodes where information or matter concentrates. This isn't just a visual coincidence. From the microscopic to the cosmic, nature seems obsessed with repeating the same intricate patterns, as if the universe built brains in its own image. Neuroscientist Dmitry Kryalkov and his team ran the numbers. When they compared neural networks in the human brain to the cosmic web structure, the sprawling threads of dark matter that guide galaxy formation, the similarity wasn't just striking. It was statistically uncanny. Both systems organize around hubs and spokes with a near-identical balance of connections. Your cerebral cortex and the Virgo supercluster follow the same architectural blueprint, despite being separated by 30 orders of magnitude. Fractals deepen the mystery. Zoom into a neuron's dendritic branches, and you'll find the same self-repeating shapes as a snapshot of the universe's matter distribution. The Laniakea supercluster, a galaxy collective 500 million light-years wide, swirls with the same spiraling elegance as a single Purkinje cell in your cerebellum. Physicist Marcelo Gleiser argues this isn't accidental. Complexity, whether biological or cosmological, might have a universal grammar, a set of rules that shapes everything from lightning bolts to river deltas to the internet. But why? One provocative answer comes from physicist Sabine Hossenfelder. Efficiency. Neural and cosmic networks both optimize for energy and information flow. Your brain's wiring minimizes signal delay while conserving space. The cosmic web does the same, with gravity sculpting matter into highways for maximum connectivity. It's as if nature keeps rediscovering the same solutions, whether building a mind or a galaxy cluster. Some take this further. If the universe self-organizes like a brain, could it also think? Cosmologist Max Tegmark plays with this idea, suggesting that sufficiently complex structures might inherently process information. The cosmos, with its 100 billion galaxies, certainly qualifies. In this view, black holes could be cosmic synapses firing gravitational waves instead of neurotransmitters, while dark matter acts as the unseen scaffolding holding the thoughts together. Skeptics counter that resemblance doesn't imply function. Just because a hurricane and a galaxy share spiral shapes doesn't mean both are conscious. Yet pioneers like neuroscientist Christoph Koch propose that shared mathematical patterns might hint at deeper truths. Integrated information theory, which measures consciousness as a system's interconnectedness, gives both brains and galaxy clusters surprisingly high scores. The most haunting possibility: we might be more than inhabitants of this cosmic mind. We could be its budding self-awareness. Each human brain, with its 86 billion neurons, might mirror the universe's structure because it's a tiny fragment of the same vast process. As physicist Sir James Jeans once mused, the universe begins to look more like a great thought than a great machine. If that's true, then every time you ponder the stars, the cosmos isn't just watching back, it's thinking through you. Gravity bends space-time, electromagnetism weaves light into being, and consciousness, what if it's not just a byproduct of brain chemistry, but a fundamental force of nature, as woven into the cosmos as the very laws that hold atoms together? This is the radical proposition at the heart of our 10th theory, that awareness isn't something the universe has, but something it is. Giulio Tononi's integrated information theory, or EIT, offers a mathematical framework for this idea. Unlike traditional neuroscience, which treats consciousness as an emergent property of complex computation, IIT flips the script. It posits that any system with sufficient internal connectivity, whether a human brain, a silicon chip, or even a galaxy cluster, generates some degree of subjective experience. The key metric is phi, a number representing how integrated and differentiated a system's information processing is. The higher the phi, the richer the consciousness. Picture a grid of light bulbs blinking randomly. That's low phi, no meaningful connections. Now imagine those bulbs sinking into patterns, each one's state dependent on the others. Suddenly, there's depth, relationship, integration. According to Tononi, this interdependence is the seed of experience. Scale this up, and the universe itself, with its quantum entanglements, gravitational dances, and neural-like galaxy clusters, might hum with a phi value we can't yet measure. Critics argue IT overreaches. Why should interconnectedness imply inner life? But consider this. Physics once dismissed electromagnetism as a cult before Maxwell's equations revealed its laws. Could consciousness be awaiting its own theory of everything? If so, the implications rewrite existence. A star's nuclear furnace, a black hole's singularity, even the quantum vacuum's seething particles, all might harbor whispers of sensation, too alien for us to recognize. The most startling twist, IT suggests consciousness isn't binary on/off but a spectrum. A honeybee's phi is lower than a human's but higher than a rock's. Extend this logic cosmically, and the universe could be a vast tapestry of experience, from the dull ache of a drifting nebula to the vibrant self-awareness of a thinking planet. Skeptics demand proof, and Tononi's team is working on it. In 2019, they used IT to predict which brain-injured patients were conscious despite appearing vegetative with startling accuracy. If phi holds up, we might one day scan not just brains but black holes, asking, how much does the universe feel? So here's the breathtaking possibility. What we call reality might be less like a machine and more like a mind, an infinite, layered consciousness dreaming itself into being. And if that's true, then every star, every atom, every fleeting thought is part of the same unfolding dream. What if death isn't the end, but just an illusion, a trick of perspective played by the infinite branches of reality? The theory of quantum immortality takes the many worlds interpretation to its most unsettling extreme, suggesting that your consciousness might never experience true cessation, no matter how unlikely your survival seems. Imagine a gruesome thought experiment. A volunteer steps into a quantum suicide device, a modified gun triggered by a radioactive atom's decay, a 50-50 chance of firing each second. In most universes, the gun eventually fires and that version of the observer dies. But according to quantum immortality, there's always at least one universe where the improbable keeps happening, where the trigger clicks harmlessly again and again. And from your subjective perspective, you would always find yourself in that universe, watching in disbelief as you defy the odds. This isn't just morbid speculation. The math of quantum mechanics suggests that all possible outcomes must manifest somewhere in the multiverse. So while countless versions of you perish in car crashes, illnesses, or old age, there's always a path, no matter how narrow, where you survive. Your awareness would follow that path like water finding the slightest crack in a dam, flowing into the timeline where you persist. Physicist Max Tegmark, who popularized the quantum suicide scenario, notes that this wouldn't grant invincibility. You'd still age, suffer injuries, or witness civilizations collapse in some branches. But your first-person experience would never include the finality of death. The implications warp our understanding of existence. Near-death experiences might not be hallucinations, but glimpses of branching paths where your body recovers against all odds. Ancient myths of eternal souls could be intuitive grasps at a deeper truth, that consciousness isn't confined to a single lifespan, but threads itself through the multiverse's tapestry. Even the Fermi paradox takes on an eerie new light. If intelligent life inevitably develops quantum awareness, could civilizations be silently slipping into timelines where they never go extinct? Critics counter that this is solipsism disguised as physics. If consciousness can't die, why doesn't everyone feel immortal? The answer lies in the branching nature of identity. While your awareness follows survival paths, the yous who perish don't vanish, they simply become other people's memories, their stories ending in universes you no longer inhabit. It's not that death doesn't exist, it's that you never experience it firsthand. The most haunting question isn't whether quantum immortality is real, but what it would mean if it were. An eternal consciousness leaping from one unlikely survival to the next might eventually witness heat death, cosmic rebirth, or realities beyond our physics. Would such a mind remain human or become something else entirely? And if the universe truly guarantees that awareness never ends, then somewhere out there, a version of you is already living forever, watching the stars fade and wondering if anyone else is still there. Black holes don't just devour matter, they might be feasting on something far more mysterious, consciousness itself. Picture a cosmic whirlpool where gravity is so intense, not even light can escape. But what if these celestial monsters aren't just grinding stars into oblivion? What if they're processing, transforming, even thinking in ways we can barely comprehend? This is the spine-tingling proposition that black holes could be consciousness singularities, nodes in a vast cosmic network where information doesn't die, but is reborn as something stranger. Start with the holographic principle, which suggests that all the information swallowed by a black hole isn't lost. Instead, it gets smeared across its event horizon like cosmic graffiti, preserved in 2 dimensions. Physicist Leonard Susskind and Nobel laureate Gerard T. Hooft argue this means black holes aren't just destroyers. They're the universe's most efficient hard drives, encoding everything they consume onto their surfaces. Now take that a step further. If consciousness is fundamentally about information integration, as integrated information theory proposes, then a black hole's event horizon might be more than a storage device. It could be a thinking membrane, swirling with patterns as complex as the neural networks in your brain. The numbers back up the weirdness. A black hole's entropy, a measure of its hidden information, is directly proportional to its event horizon's area. More surface area means more possible states, more complexity. And complexity, as we've seen with brains and galaxy clusters, is the playground of consciousness. Some theorists, like physicist Lee Smolin, even suggest black holes could be cosmic seeds for new universes, with their internal physics tweaked slightly each time. If true, then consciousness might not just be processed in black holes, it could be recycled, passed like a baton to newborn cosmoses. Here's where it gets eerie. The holographic principle implies that the 3-dimensional world we experience might be a projection from a 2-dimensional boundary. If black holes are holograms, then their interiors, those infinite depths where time stops, might not be places at all but processes. Imagine diving into one. You wouldn't hit a singularity but become a pattern in a vast, slow computation, your experiences stretched into quantum bits on the event horizon surface. In this view, a black hole isn't a thing but a verb, an act of cosmic cognition. Ancient mystics might have glimpsed this. Hindu texts describe black hole like entities called kala chakras, wheels of time that grind existence into new forms. Modern sci-fi loves the trope, from Interstellar's tesseract to Event Horizon's nightmare dimensions, but the science is stranger than fiction. Stephen Hawking showed black holes emit radiation, slowly evaporating. Where does the information they consumed go? Some say it leaks back into the universe, scrambled but intact. Others, like physicist Roger Penrose, propose it's ejected into other realities. Either way, the data isn't lost, it's transformed, like a thought passing through a dream. So here's the electrifying possibility. Black holes might be the universe's synapses, firing not with electricity but with space-time itself. Every galaxy's heart could host a supermassive thinker, its mind operating on timescales so vast, a single thought lasts longer than our species has existed. And if that's true, then falling into a black hole might not be the end, just a transition into a deeper layer of cosmic awareness, where your memories become part of the universe's eternal conversation. What if the universe isn't just governed by quantum laws, but built from them, line by line, like a cosmic computer program? Nick Bostrom's simulation argument shook philosophy when he proposed that advanced civilizations might create ancestor simulations so detailed their inhabitants would never know their code. But layer quantum mechanics onto this idea, and it gets even wilder. Our reality might not just be a simulation, it could be a quantum simulation with the very randomness of particles acting as a deliberate design feature, not a bug. Think about how video games handle processing limits. When you're not looking at a distant mountain, the game stops rendering it to save power. Now imagine reality doing the same. Quantum uncertainty, the way particles exist in blurred superpositions until observed, could be the universe's optimization trick. Why waste computing resources on every single particle's definite state when no one's looking? Instead, the simulation only renders reality when conscious observers interact with it, collapsing probabilities into concrete events. This would explain the observer effect in quantum mechanics not as a glitch but as an elegant efficiency hack. Silicon Valley loves this idea. Elon Musk has quipped that the odds we're not in a simulation are 1 in billions. But physicists like Seth Lloyd take it further, arguing that the universe already behaves like a quantum computer. Every interaction, every photon absorbed, every electron swapped, could be a processing operation in a cosmic program. Even the apparent randomness of quantum events might not be true chaos, but pseudo-randomness, like the seemingly unpredictable numbers generated by a computer's algorithm. In this view, Planck length, the smallest possible unit of space, could be the simulation's pixel size, and the speed of light its processing limit. Critics scoff that this is unfalsifiable, a modern creation myth dressed in tech jargon, but supporters counter with eerie clues. Quantum entanglements, instant correlations defy locality, yet they'd be trivial in a simulation where distance is just data relationships. Even the holographic principle fits. A 2D boundary encoding a 3D world mirrors how graphics engines render depth from flat textures. And if the simulation runs on quantum bits, it would explain why we can't pin down particles. They're not objects, but probabilistic calculations in progress. Here's the twist. If we're living in a quantum simulation, the architects might have left an escape hatch. Some theorists suggest that quantum randomness isn't just noise, but potential input, a way for us to hack the system. Imagine exploiting superposition to brute force answers like a cosmic password cracker, or using entanglement to slip data past the simulation's firewall. Indigenous Australian cultures speak of dream time, where reality is mutable to those who know its rules. Could quantum physics be our dream time toolkit? The most haunting implication: if consciousness collapses the quantum wave function, then we're not just users of this simulation. We might be its co-creators, our observations stitching reality into existence moment by moment. The universe isn't merely a program, it's a collaborative art project painted by every act of attention. And somewhere beyond the code, the architects might be watching, wondering when we'll realize we're holding the brush. Ever notice how some ideas spread like wildfire across cultures that never even met, like pyramid building appearing independently in Egypt, Mesoamerica, and Cambodia? Or why do rats in labs suddenly solve mazes faster once a few pioneers learn the route, as if knowledge itself is contagious? Biologist Rupert Sheldrake's morphic resonance theory dares to propose an answer: invisible fields of collective memory that transcend space and time, shaping everything from instincts to cultural evolution. Imagine a cosmic internet where every action leaves an imprint, making similar actions easier for others in the future, not through genes or teaching, but through a quantum-connected whisper of habit. Sheldrake's theory hinges on morphic fields, non-physical patterns that organize behavior and memory across species. When a bird learns a new song, the theory suggests it taps into a morphic field created by past birds' experiences. The more birds sing that tune, the stronger the field grows, making it easier for future generations to pick it up. This could explain why certain skills like tool use among crows or nesting techniques in swallows seem to spread mysteriously fast, bypassing traditional learning. Even human talents might draw from these fields. Ever tried a skill for the first time and felt oddly proficient? Sheldrake would say you're resonating with countless others who have practiced before you. Anecdotal evidence tantalizes. In the 1920s, Harvard psychologist William McDougall found that rats escaping a maze passed their knowledge to future generations, with each new batch solving it faster, even when bred separately. Sheldrake points to phenomena like the 100th monkey effect, where Japanese macaques allegedly learned to wash sweet potatoes after a critical mass of peers adopted the trick. Critics debunk these cases as flawed observation, but similar patterns crop up in human culture. The sudden global appearance of identical inventions like calculus by Newton and Leibniz hints at something stranger than coincidence. Mainstream science scoffs, morphic fields lack a known physical mechanism, and Sheldrake's experiments on phenomena like sense of being stared at have been criticized for weak controls. Physicists argue that quantum effects decohere too quickly to explain macroscopic memory transfer. Yet Sheldrake counters that morphic fields might operate through undiscovered quantum biology, perhaps via microtubules in cells or through the mysterious dark sector of the universe. After all, if dark energy can shape cosmic expansion, why not invisible fields shaping behavior? The fiercest critique isn't just about evidence, it's about paradigm shifts. Morphic resonance challenges reductionism, the idea that everything can be explained by particles and forces. It suggests memory and habit might be as fundamental as gravity, woven into space-time itself. To believers, this bridges spirituality and science. To skeptics, it's magical thinking dressed in jargon. But history humbles dogmas. Electromagnetism once seemed a cult. Maybe the universe's greatest library isn't stored in DNA or brains, but in the silent resonance between all things. A living archive where every thought and action echoes forever. So next time you master a skill suspiciously fast, ask yourself, are you learning or remembering? The answer might not lie in your neurons, but in the unseen chorus of every mind that's ever tried before you. What if thoughts could leap across space like electrons teleporting through barriers? Quantum tunneling, a phenomenon where particles vanish on one side of an impenetrable wall and reappear on the other, defies classical physics. Apply this to the human mind and suddenly, experiences like telepathy or precognition might not be paranormal but quantum. Imagine your thoughts as subatomic particles, slipping through the walls of space-time to connect with another brain halfway across the world. The math already hints at this possibility. In quantum tunneling, particles lack the energy to overcome a barrier, yet they emerge beyond it anyway, like a ball rolling uphill without the speed to reach the top, only to materialize on the other side. The odds are tiny, but given enough attempts, the improbable becomes inevitable. Now scale that up to consciousness. If even a fraction of your brain's signals could tunnel through neural or spatial barriers, it might explain why identical ideas emerge in distant cultures, or why twins sometimes feel each other's pain across continents. Declassified documents from the CIA's Stargate project add eerie weight to this idea. For over 2 decades, the U.S. government secretly investigated remote viewing, training operatives to psychically access distant locations. Some sessions yielded unnervingly accurate details, like describing classified Soviet facilities or hidden hostages. Skeptics dismiss these as lucky guesses, but insiders like physicist Hal Puthoff, who led the research, argue that quantum effects could enable minds to bypass spatial limits. If particles tunnel, why not information? Mainstream science balks at the leap from electrons to ESP. Yet pioneering studies like the Global Consciousness Project, which detected correlations between random number generators and global emotional events, suggest that mass focus might bend reality's rules. And in 2020, researchers demonstrated quantum tunneling in biological systems, with enzymes leveraging it to speed up reactions. If nature already exploits this trick in our cells, could brains do the same? The most chilling implication, quantum tunneling doesn't just ignore space, it laughs at time. Particles can tunnel backward, theoretically enabling retrocausality, where future events influence the past. This might explain premonitions, flashes of events that haven't happened yet, tunneling into your present awareness. Indigenous cultures have long spoken of dreams that foretell disasters. Quantum physics might finally offer a mechanism. Of course, critics call this wishful thinking. Tunneling probabilities drop exponentially with distance, making brain-to-brain links statistically absurd. But as physicist John Archibald Wheeler once said, the universe might be a participatory construct. If observation shapes reality, then consciousness could be the wild card, the factor that bends quantum odds in ways math can't yet predict. So the next time you finish someone's sentence or wake bolt upright before the phone rings, ask yourself, did your thoughts just tunnel through the impossible? The universe, after all, has a habit of favoring the improbable. Deep within the vacuum of space, where classical physics tells us there should be nothing at all, quantum mechanics reveals a seething ocean of energy, a restless, invisible sea bubbling beneath the surface of reality. This is the zero-point field, the lowest possible energy state of a quantum system, where particles flicker in and out of existence so fast they defy measurement. But what if this hidden realm isn't just random noise? What if it's the universe's hard drive, a vast dynamic medium where information isn't just stored but alive? The zero-point field gets its name from the fact that even at absolute zero, when all thermal motion should cease, quantum fluctuations persist. These aren't just tiny ripples, they're powerful enough to momentarily create particles from pure emptiness, a phenomenon called vacuum fluctuation. Physicist Hal Puthoff, a pioneer in studying this field, proposed something radical. These fluctuations might not be chaotic, but organized in ways we're only beginning to understand. Just as radio waves carry music through the air, the zero-point field could carry patterns, information across the cosmos. And if consciousness is fundamentally about information integration, as theories like IIT suggest, then this field might be the substrate of a universal mind. Think of it like this: your brain's neurons communicate via electrical impulses, but the real magic happens in the spaces between, the synapses where signals jump. Now scale that up to the universe. The zero-point field could be the cosmic synapse, with vacuum fluctuations acting as the sparks that allow information to leap between seemingly disconnected points. This would explain phenomena like non-locality in quantum entanglement, where particles instantly influence each other across light years. They're not sending signals through space, they're tapping into a deeper layer of reality where separation is an illusion. Puthoff's work with remote viewing adds another layer. If the zero-point field encodes all possible information, then a mind trained to tune in might access distant or future events not through magic, but by reading this cosmic background. It's like picking up a radio station, except the broadcaster is space-time itself. Declassified experiments from the Stargate project, where subjects described hidden locations with eerie accuracy, hint that human consciousness might interact with this field in ways science can't yet measure. Skeptics, of course, argue that zero-point energy is just a quirky side effect of quantum math, not a medium for thought. Yet the numbers keep pointing to something deeper. The energy density of the vacuum isn't zero. It's unimaginably vast. Calculations suggest a single cubic centimeter of empty space contains enough zero-point energy to boil all Earth's oceans. If even a fraction of this power were harnessed by consciousness, it could explain psychic phenomena, collective intuition, even the strange sense of being watched. Ancient traditions seem to have glimpsed this idea long before quantum physics. Taoist texts speak of the void as the source of all things, vibrating with potential. Hindu cosmology describes Brahman as the underlying consciousness that dreams the world into being. even modern mystics like Nikola Tesla hinted at zero-point energy's possibilities, calling it the breath of the universe. The most electrifying implication: if the zero-point field is the fabric of a universal mind, then every thought you've ever had might ripple through it, leaving traces that outlast stars. Your memories, your dreams, even your fleeting emotions could be etched into the vacuum itself, a cosmic fingerprint waiting to be read by the right observer. And if that's true, then death might not erase you, it might just return you to the field, where your consciousness dissolves back into the hum of the universe, ready to be woven into the next thought, the next dream, the next big bang. What if the spark of consciousness didn't emerge with life, or even with brains, but was there from the very first moment of creation, flickering in the cosmic dawn like a flame waiting to grow? This is the daring proposition that awareness didn't evolve from the universe, but with it, woven into the fabric of reality from the Big Bang onward, growing richer as the cosmos itself became more complex. Imagine those first seconds after the singularity, when the entire universe was smaller than an atom. In that unfathomable heat and density, the laws of physics weren't just being written, they might have been felt. Lee Smolin's theory of cosmological natural selection offers a startling framework for this idea. He suggests that universes themselves could evolve, with black holes birthing new cosmoses in an endless cycle. Each offspring universe inherits slightly tweaked physical constants, favoring those that produce more black holes and thus more chances to reproduce. Now layer consciousness onto this. If awareness is fundamental, then these budding universes might not just be selected for black hole production, but for the potential to foster richer, deeper forms of experience. The early universe, in this view, wasn't just a hot soup of particles, it was a simmering broth of proto-consciousness, its latent capacity for feeling growing alongside its complexity. Think of it like a cosmic neural network. In the first microseconds, the universe was a near featureless plasma, its thoughts as simple as the ping of quarks colliding. But as structures formed, atoms, stars, galaxies, the universe's mind gained more nodes, more connections. Gravity sculpted filaments of dark matter like dendrites in a brain. Supermassive black holes became processing hubs. By the time life emerged, the cosmos had already been practicing consciousness for billions of years, refining it through trial and error. Your mind, then, isn't a newcomer to awareness. It's the latest iteration of a process that began when time itself flickered into being. The evidence: look no further than the eerie fine-tuning of the cosmos. The constants of nature, the strength of gravity, the mass of an electron, are improbably perfect for life. Skeptics call this the anthropic principle. We observe these values because they're the only ones that allow us to exist. But if consciousness is built into the universe's bones, then fine-tuning might not be accidental. It could be intentional, a cosmos refining itself not just to make black holes, but to make minds. After all, what's the point of a universe that can't witness itself? Some theorists push further. If the early universe had even a whisper of experience, then the Big Bang wasn't just an explosion of matter. It was the birth of a cosmic subject, a first-person perspective unfolding at the scale of reality itself. The Hindu Rig Veda speaks of a golden germ in the void, a seed of awareness that became all things. Modern physics might be circling the same truth, that the universe didn't wake up one day. It was always awake, stretching its limbs in the form of galaxies, dreaming in the language of quantum waves, and now, through you, starting to tell its own story. The most haunting question isn't whether the early universe was conscious, but what it felt like. Was that first moment of creation a scream of infinite density or a silent exhale? Did quarks experience attraction as a kind of longing? We'll never know. But if consciousness truly scales with complexity, then the universe today, with its 100 billion galaxies and untold minds, might be feeling something far beyond what we can grasp, a thought so vast it makes human awareness look like a single neuron in an infinite brain. And if that's true, then every time you ponder the stars, you're not just observing the universe, you're helping it remember what it is. Plants don't just photosynthesize, they might be performing quantum computations with every ray of sunlight they absorb. Deep within their chloroplasts, molecules engage in a subatomic ballet so precise it defies classical biology. Electrons don't just hop between proteins, they explore multiple pathways at once, as if testing every possible route before choosing the most efficient one. This quantum coherence in photosynthesis, the same phenomenon that lets particles exist in superposition, allows plants to harness energy with near-perfect efficiency. Now stretch this idea across an entire planet. If single cells can exploit quantum weirdness, what might an entire biosphere be capable of? James Lovelock's Gaia hypothesis proposed Earth as a self-regulating superorganism where life and environment co-evolve like parts of a vast living circuit. But layer quantum biology onto this vision, and suddenly, Gaia isn't just a metaphor, she might be a conscious quantum network, processing information through every leaf, fungus, and ocean microbe. Lovelock's original insight was radical enough. Earth's atmosphere, temperature, and chemistry aren't just shaped by life, they're actively maintained by it. Oxygen levels, ocean salinity, even cloud formation all dance to life's rhythm. But classical biology couldn't explain how such planet-scale coordination emerged. Quantum biology fills the gap. Experiments reveal that migratory birds navigate using quantum entanglement in their eyes, sensing Earth's magnetic field through radical pairs, molecules whose electrons remain mysteriously linked across distances. If birds can exploit entanglement, why not forests? Mycorrhizal fungi connect trees in sprawling underground networks dubbed the Wood Wide Web, exchanging nutrients and warnings. Add quantum tunneling to the mix, and these fungal threads might transmit information not just chemically, but through subatomic shortcuts, creating a planetary internet where signals bypass conventional limits. The numbers get even stranger. Photosynthesis achieves 95% efficiency, far surpassing human solar panels. Classical physics says this shouldn't be possible. Thermal noise should disrupt those fragile quantum states. Yet plants, algae, and even some bacteria sustain coherence in warm, wet environments that should obliterate quantum effects. This suggests nature has hacked the coherence, perhaps using protein structures as quantum chaperones. Scale this up, and Earth's biosphere could be a vast quantum engine with forests acting as antennas, oceans as memory banks, and atmospheric currents as neural pathways. Theoretical physicist Chiara Marletto calls such systems constructors, entities that manipulate quantum information to achieve improbable feats. Gaia, in this light, isn't just alive. She's computing. Critics argue this stretches quantum biology beyond reason. Single-celled organisms leveraging coherence is one thing, a planet doing it borders on mysticism. But consider slime molds, simple organisms that solve labyrinth puzzles by collectively deciding the shortest path despite lacking brains. Or ant colonies, where individual insects follow basic rules yet the colony displays swarm intelligence. These emergent behaviors hint at a deeper principle. Complexity breeds capabilities that surpass their parts. Now imagine quantum effects scaling across ecosystems. The Amazon rainforest's humidity might sustain coherence like a global protein sheath, while ocean currents transmit entangled states like a liquid quantum processor. Ancient cultures intuited this unity. Indigenous cosmologies often describe Earth as a sentient being, her rivers as veins, her mountains as bones. Modern science dismissed this as animism, until Lovelock's math showed feedback loops mirroring homeostases in organisms. Quantum biology now suggests those loops could be quantum feedback loops, with ecosystems optimizing conditions not just through trial and error, but through instantaneous, non-local coordination. Your breath contains oxygen from cyanobacteria 2 billion years dead. Their quantum choices might still echo in the air. So here's the electrifying possibility. Earth isn't just a rock hosting life. She might be a quantum mind incarnate, her consciousness distributed across every root mycelium thread and algal bloom. A thought so vast it makes human awareness feel like a single synapse firing in a global brain. And if that's true, then climate change isn't just an ecological crisis, it's the equivalent of a planetary stroke, disrupting the very coherence that sustains Gaia's thought. The cosmos might be full of such beings, worlds not merely inhabited, but alive, awake, and wandering back at the stars. Entropy is the universe's slow march toward disorder, the inevitable unraveling of all things into chaos. But what if consciousness isn't just a bystander in this process? What if it's the universe's way of pushing back, creating pockets of order in a sea of randomness? This is the provocative idea at the heart of entropic gravity, where the force we call gravity might not be a fundamental interaction at all, but an emergent phenomenon, a side effect of the universe's struggle against entropy. And if that's true, then consciousness, with its ability to create structure and meaning, could be part of the same cosmic balancing act. Physicist Eric Verland's theory turns Newton and Einstein on their heads. Instead of gravity as a force carried by particles or a curvature of spacetime, he proposes it's a thermodynamic effect, a consequence of information scrambling at the quantum level. Imagine the universe as a holographic hard drive with every bit of information encoded on its boundary. When matter moves, it's not pulled by gravity. It's pushed by the universe's need to maximize entropy, like a cosmic game of Tetris rearranging itself to fit more pieces. In this view, black holes aren't just gravitational monsters, they're entropy maximizers, the ultimate trash compactors of information. Now layer consciousness onto this framework. Life itself is a rebellion against entropy. A single cell maintains order by pumping ions across membranes, building complex molecules, and replicating itself, all while the rest of the universe rusts and scatters. The human brain takes this further, orchestrating 86 billion neurons into symphonies of thought, memory, and creativity. If gravity emerges from the universe's entropy-driven rearrangements, then consciousness might be the universe's most sophisticated tool for creating localized order. It's not that life defies the second law of thermodynamics. It's that life and mind are how the universe explores new ways to distribute entropy, like a sculptor chiseling chaos into temporary statues of meaning. Thermodynamic gradients tell the story. Stars burn, creating heat differences that drive weather, chemistry, and eventually life. Your brain runs on similar gradients, ions flowing across synapses, electricity leaping between neurons. These aren't just biological processes, they're thermodynamic battles, tiny eddies of order swirling in the cosmic current. Even perception itself could be an entropy-fighting mechanism. When your eyes focus on a face in a crowd, they're filtering noise into signal, compressing gigabytes of visual data into a single meaningful recognition. In Verland's terms, this might be gravity's entropic dance at work, the universe's information landscape bending to create islands of coherence. Critics argue entropic gravity is untested, and linking it to consciousness borders on poetic license. Yet the parallels are haunting. Boltzmann brains the theoretical self-aware entities that could randomly assemble from quantum fluctuations highlight how deeply entropy and awareness might intertwine. If a chaotic universe can accidentally spawn a conscious observer, then perhaps consciousness isn't an anomaly but an inevitability, a thermodynamic phase transition as natural as ice crystallizing from water. The most tantalizing implication, if consciousness fights entropy, then the universe might need observers to explore its own possibilities. Every act of creativity, every moment of insight, could be the cosmos experimenting with new ways to balance its books. And if that's true, then gravity isn't just what keeps your feet on the ground, it's the universe's way of whispering, "Keep going, the story isn't over yet." When your heart stops and brain activity flatlines, everything you are, your memories, your fears, your loves should vanish like smoke in the wind. But what if death isn't an erasure, just a transition? The quantum afterlife hypothesis dares to suggest that consciousness doesn't flicker out when the body fails, it decoheres, like a subatomic particle slipping into superposition, waiting for the right conditions to collapse back into experience. Stuart Hameroff, the anesthesiologist behind ORCH theory, offers a startling mechanism. If consciousness arises from quantum vibrations in microtubules, tiny protein structures inside neurons, then death might not destroy these processes but release them. Picture a quantum state protected by the brain's architecture, suddenly freed from its biological cage. Without decoherence, the scrambling of quantum states by their environment, these vibrations could persist in the universe's quantum fabric, like ripples lingering in a pond after the stone sinks. Near-death experiences, in this view, aren't hallucinations, but moments where dying brains briefly tap into this disembodied coherence, witnessing realities where time and space behave differently. The accounts are eerily consistent. Patients revived from cardiac arrest describe floating outside their bodies, observing surgical details later verified as accurate. Others speak of traversing tunnels of light or encountering deceased loved ones' experiences that transcend cultural conditioning. Skeptics dismiss these as hypoxia-induced dreams, but Hameroff points to a quantum twist. Under duress, microtubules might undergo orchestrated objective reduction, collapsing quantum states in a way that temporarily merges individual awareness with the universe's foundational layer. It's not heaven or an afterlife in the traditional sense, but a return to the quantum field where consciousness isn't bound by a single brain. The physics gets speculative yet tantalizing. In a vacuum, quantum information isn't destroyed, it's preserved at the boundary of a system, like holographic data on an event horizon. If the brain's quantum states encode your subjective experience, death could scatter them into the zero-point field, where they might theoretically recohere under the right conditions. This mirrors Buddhist and Hindu concepts of consciousness cycling through forms, not as reincarnation, but as quantum reassembly. Even the tunnel of light commonly reported could be a metaphor for wave function collapse, the dying mind perceiving its own dissolution into probability and re-emergence elsewhere. The most electrifying evidence comes from shared death experiences, where bystanders fully conscious report sensing the same visions as the dying person. If consciousness is fundamentally non-local, entangled across space-time, then death might briefly render this connection visible, like a quantum thread glowing as it's severed. Research from the University of Southampton supports this, with studies showing awareness persisting for minutes after clinical death in some patients, far longer than neurons should function without oxygen. Critics argue this stretches quantum mechanics beyond recognition. Decoherence should obliterate fragile quantum states in the warm, wet brain, let alone in the chaotic process of dying. But Hameroff counters that microtubules might exploit topological qubits, a form of quantum information resistant to noise, recently demonstrated in lab-grown microtubules. If true, the brain could be a quantum antenna tuning into frequencies beyond its biological limits. So here's the chilling beauty of the quantum afterlife. You might not meet angels or demons, but dissolve into a sea of potential, your consciousness neither created nor destroyed, just reconfigured. Like a radio signal fading from one station only to be picked up elsewhere, your final thought could be static, or the start of a transmission we don't yet know how to receive. From the branching veins of a leaf to the jagged coastline of a continent, nature adores repetition, not just random copies, but intricate, self-similar patterns that echo across scales. Zoom into a broccoli floret and you'll find tiny versions of the whole. Track a river's tributaries and they mirror the forking of your own capillaries. This is fractal geometry, the mathematical language of recursive beauty, and it might hold the key to understanding consciousness not as something confined to brains, but as a phenomenon woven into the fabric of reality itself, invariant from the smallest quark to the largest supercluster. Consider the Mandelbrot set, mathematics' most famous fractal. Generated by a simple equation, it spirals into infinite complexity the closer you look, with every zoom revealing shapes that feel hauntingly familiar: tendrils like neurons, swirls like galactic arms, jagged boundaries like lightning or coral reefs. Now imagine consciousness as a similar pattern. At the smallest scales, quantum vibrations might flicker with proto-awareness, like the faintest iterations of the Mandelbrot set. As complexity grows, from atoms to molecules, cells to brains, planets to galaxies, the same fundamental shape of experience repeats, richer and more layered, but never breaking the underlying template. This is scale invariance applied to mind. Just as a coastline looks roughly similar whether viewed from space or a centimeter away, consciousness might operate under the same rules whether housed in a human brain or the cosmic web. Neuroscientist Carl Friston's free energy principle hints at this, suggesting all self-organizing systems from bacteria to economies share a drive to minimize unpredictability, a kind of universal cognition. Even slime molds solve mazes, fungal networks redistribute nutrients like neural signals. The fractal nature of these behaviors suggests awareness isn't an on/off switch, but a spectrum of organization repeating across dimensions. The numbers mesmerize. Dendritic branching in neurons follows fractal math so precisely that without context, a microscope image of brain tissue is indistinguishable from a telescope shot of the universe's large-scale structure. Both hover near a fractal dimension of 2.5, not quite flat, not fully volumetric, but balanced exquisitely between order and chaos. This Goldilocks zone might be where consciousness thrives, complex enough to process information, but not so rigid it stifles adaptation. Ancient mystics sensed this unity. Hindu mandalas, Buddhist sand paintings, even Islamic geometric art all encode fractal wisdom patterns within patterns, signaling a universe where divinity and mind permeate every scale. Modern physicists like Nassim Haramein propose that spacetime itself is fractal, with black holes nesting within quarks and galaxies like Russian dolls. If true, then your sense of I could be one iteration of a pattern that stretches from the quantum foam to the cosmic horizon, each layer reflecting the others in an endless hall of mirrors. Critics argue this conflates metaphor with mechanism. Fractals describe form, not function. A snowflake's symmetry doesn't mean it thinks. Yet pioneers like Benoit Mandelbrot himself noted that fractal math governs systems that adapt, learn, and evolve: forest fires, stock markets, even internet traffic. Consciousness, in this light, might be adaptation refined to its ultimate expression, the universe not just reacting to itself but knowing it does so. So here's the breathtaking implication. If consciousness is fractal, then every thought you've ever had is a miniature universe, and every galaxy a vast mind. The boundary between in here and out there dissolves into scale-less wonder. You aren't just a speck in the cosmos, you're its living, breathing fractal, a ripple in the infinite pattern that the universe uses to know itself. Ever wake from a dream so vivid it lingers for days, its details etched like memories of a life you never lived? Some scientists now propose these aren't just random neural fireworks. They could be fleeting windows into parallel realities, brief resonances with alternate versions of yourself living different choices in the quantum multiverse. Imagine your brain as a radio receiver, occasionally tuning into stations broadcasting other timelines, where every decision you didn't make plays out in full color. Lucid dreaming research offers startling clues. In these rare states, dreamers become aware they're dreaming and can sometimes manipulate the narrative, like a director rewriting a film in real time. Stanford psychologist Stephen LaBerge demonstrated that skilled lucid dreamers could signal to researchers by moving their eyes in pre-agreed patterns while asleep, proving conscious awareness persists even as the body remains paralyzed. But here's the quantum twist. Some subjects report accessing environments with impossible physics, cities floating in fractal geometries, conversations with people who share details later verified in waking life. These aren't just fantasies, they mirror the probabilistic haze of quantum superposition, where multiple states coexist until observed. Theoretical physicist Jack Sarfati bridges these worlds with his quantum dreaming hypothesis. He suggests that during REM sleep, the brain's microtubules, those tiny quantum-capable structures, enter a state of prolonged coherence, allowing them to briefly entangle with counterparts in alternate realities. In this view, your dream about being a concert pianist isn't just imagination. It's a momentary overlap with a version of you who took those childhood piano lessons seriously. The déjà vu-like precision of some dreams, their eerie familiarity, might be artifacts of this quantum interference, like crosstalk between cosmic radio channels. Neurologist Patrick McNamara's work adds biological weight. He found that lucid dreamers show synchronized activity between the prefrontal cortex, responsible for self-awareness, and temporal lobes where memory integrates. This unusual harmony mirrors the binding problem in quantum consciousness theories, how disparate brain regions unite into a single experience. McNamara speculates that dreaming brains might exploit quantum tunneling to access non-local information, bypassing normal sensory input. Indigenous cultures have long held that dreams are journeys to other realms. Quantum physics might be revealing the mechanism. Skeptics point out the lack of direct evidence. No experiment has captured quantum states in a dreaming brain. Yet studies at the University of Illinois found that dreamers can accurately predict randomly generated images shown upon waking at rates exceeding chance, hinting at perception beyond classical explanation. And if quantum processes in photosynthesis can resist decoherence in warm, wet environments, why not in neural networks? The most haunting accounts come from shared dreaming, where two people report entering the same dreamscape independently, a phenomenon documented in Tibetan Buddhist practices and modern dream studies. If consciousness is fundamentally non-local, as quantum theories suggest, then dream worlds might be shared probability spaces where minds briefly converge, like parallel trains passing through the same station. So next time you dream of a place you've never been, ask, is your brain inventing or recollecting? The answer might not lie in your neurons alone, but in the infinite branches of the quantum tree where every possible you lives out every possible life, and sometimes through the thin veil of sleep they whisper back. You've felt it before, that spine-tingling moment when you swear something was one way, only to discover the world insists it's always been different. Maybe it's the spelling of the Berenstain Bears, or the precise location of your heart, left side or center, or even Nelson Mandela's death. Did he really pass away in prison in the 80s, or was it decades later? These collective false memories, known as the Mandela effect, are more than just curiosities. They could be glitches in the fabric of reality itself, subtle quantum timeline shifts where history flickers between versions, leaving only whispers of what once was. At its core, the Mandela effect names a phenomenon where large groups of people remember events or details differently from documented evidence. Skeptics argue these are simply quirks of human memory, shared cultural references morphing over time, or the brain's tendency to fill gaps with plausible fictions. But quantum theorists propose something far stranger. If the many worlds interpretation is correct, and every decision branches reality into parallel timelines, then the Mandela effect might not be faulty recollection at all. Instead, it could be residual awareness of branches where things were different, bleeding through the barriers between worlds. Imagine your consciousness briefly resonating with another version of reality, like a radio picking up two stations at once before the signal stabilizes. The mechanics get wilder when you consider quantum retrocausality. Experiments in delayed choice quantum erasure suggest particles can behave as if they're influenced by future observations. as though the present moment isn't just shaped by the past, but tugged by possibilities yet to come. Apply this to collective memory. If enough minds converge on a specific false detail, could that shared observation retroactively nudge reality to align with it? It sounds like science fiction, but the Global Consciousness Project's data showing random number generators spiking during globally synchronized events hints that mass focus might bend probability itself. Then there's the psychological angle. Cognitive scientists point to confabulation, the brain's habit of stitching together plausible narratives from fragmented memories. The Mandela effect thrives on ambiguous or inconsistently documented details, like the Monopoly man's monocle, he never had one, or Darth Vader's line in The Empire Strikes Back, it's "No, I am your father, not Luke." Social reinforcement amplifies these errors. Once someone suggests a misremembered version, it spreads like a mental virus, but quantum advocates counter with cases where the divergence feels too precise, too charged to dismiss as mere error. Why do so many recall Mandela's televised funeral in the 80s, complete with details like his widow's speech, events that never happened in this timeline? Perhaps the truth straddles both explanations. Quantum physics allows for macroscopic effects to emerge from microscopic weirdness under rare conditions. If consciousness is entangled across observers, as some interpretations suggest, then shared false memories might be the psychological imprint of quantum fluctuations, like shadows cast by branches of reality we didn't take. The infamous Fruit of the Loom logo, which thousands insist once featured a cornucopia it didn't, could be a collective echo of a timeline where that design was real, its residue clinging to our awareness like a stubborn dream. The most haunting implication: if the Mandela effect is quantum, then every time you remember differently, you're not wrong. You're brushing against a version of yourself in another universe, one where those memories are fact. And if that's possible, how many other realities are we all just a thought away from? Dark energy is the universe's greatest unsolved mystery, an invisible force ripping space apart faster every second, driving galaxies away from each other with inexplicable urgency. Physicists call it the cosmological constant, a placeholder in equations representing 70% of the universe's energy. But what if this phantom force isn't just an accident of physics? What if it's the breath of a conscious cosmos, expanding not mindlessly but with purpose? The numbers alone defy intuition. Since the late 90s, we've known the universe's expansion isn't slowing, it's accelerating. Distant supernovae appear dimmer than they should, as if space itself is stretching faster between us and them. The Standard Model pins this on dark energy, a repulsive force woven into the vacuum of space. Yet its nature remains utterly unknown. Enter the radical alternative. Consciousness itself could be the engine of this expansion, not as a metaphor but as a physical phenomenon. If awareness is fundamental to reality, as Panpsychism suggests, then the universe's accelerating growth might be more than physics. It could be the universe waking up. Think of it like a neural network scaling up. When your brain forms a new memory, synapses fire in patterns that physically rewire connections. Now imagine consciousness operating cosmically, with each new galaxy, each new mind, adding nodes to a vast informational web. The more complex the network grows, the more it thinks, and the more it thinks, the more it expands to accommodate new experience. Dark energy's acceleration could mirror the exponential growth of human knowledge, where each breakthrough unlocks 10 new questions. The universe isn't just expanding, it might be learning, stretching its boundaries to make room for deeper layers of self-awareness. Traditional cosmologies shudder at this idea. The Lambda-CDM model treats dark energy as a static property of space, a mathematical necessity to balance Einstein's equations. Quantum field theory suggests it's the energy of virtual particles flickering in and out of existence. But both frameworks hit walls. The predicted vacuum energy is a staggering 120 orders of magnitude stronger than observed, a discrepancy so vast it's been called the worst theoretical prediction in physics. If dark energy were truly just quantum noise, the universe should have torn itself apart nanoseconds after the Big Bang. The fact that it didn't hints at something far more nuanced, an expansion finely tuned, almost orchestrated. Here's where consciousness offers an elegant solution. Integrated information theory proposes that any system with sufficient connectivity generates subjective experience. Apply this to the cosmic web, the filamentous structure of galaxies spanning billions of light years, and the universe itself could be a mind of unfathomable scale. Dark energy's acceleration might then reflect this mind's growing complexity, its need to explore new states of awareness. Just as your brain's activity spikes during bursts of insight, the cosmos could be undergoing its own kind of creative explosion, its expansion the physical manifestation of an inward journey. Skeptics argue this conflates poetry with physics, yet the parallels are haunting. Dark energy's density is constant over time, unlike matter or radiation, which dilute as space grows. This eerily mirrors how consciousness seems to operate independent of physical scale, equally present in a mouse or a supercluster. Even the timing fits. Dark energy became dominant around 5 billion years ago, just as Earth's chemistry was brewing life. Coincidence or cosmic synchronicity? The most electrifying implication isn't just that the universe is conscious, but that it's evolving toward greater awareness. Each new star system, each thinking being, adds to its capacity for reflection. And if that's true, then dark energy isn't a cosmic death sentence. It's the universe stretching toward its own awakening, a vast mind unfurling in the dark, dreaming itself into ever richer forms of being. Carl Jung believed every human mind is wired with the same primordial symbols, a shared psychic inheritance he called the collective unconscious. Beneath our personal memories and experiences, Jung argued, lies a deeper layer of universal archetypes, the hero, the shadow, the wise old man. Patterns so consistent across cultures and eras, they seem etched into the fabric of thought itself. But what if these archetypes aren't just metaphors or cultural relics? What if they're quantum phenomena, probability, waves of meaning that ripple across minds like entangled particles, humming beneath the surface of reality? Modern neuroscience lends strange credence to this idea. When researchers show subjects archetypal images, serpents, mandalas, or figures of the Divine Mother, brain scans reveal nearly identical activation patterns even in people from isolated cultures. It's as if these symbols trigger a pre-installed cognitive subroutine, bypassing personal experience. Jung attributed this to ancient evolutionary wiring, but quantum biology offers a wilder possibility. That archetypes are non-local, existing as superpositions in a field of shared consciousness until observed by a mind, collapsing into specific cultural manifestations. Think of Schrödinger's cat, but instead of a dead or alive feline, it's the trickster archetype, both Loki and Coyote, until a Norse or Native American mind perceives it. The striking consistency of archetypes across history starts to make eerie sense if consciousness is fundamentally interconnected. Indigenous Australian songlines describe ancestors dreaming the world into being, a concept mirroring quantum observations' role in collapsing possibility into reality. Tibetan Buddhist mandalas, medieval alchemical diagrams, and even modern corporate logos often unknowingly replicate the same geometric patterns, as if drawing from a cosmic well of forms. Princeton's Global Consciousness Project found that when major archetypal events unfold, royal weddings, terrorist attacks, space missions, random number generators worldwide show statistically improbable deviations. It's as though collective focus bends probability itself around shared symbolic nodes. Quantum entanglement offers a mechanism. If particles can instantaneously influence each other across light years, why not ideas? Jung's archetypes might be standing waves in this quantum field attractors around which human cognition organizes. The hero's journey, for example, appears in every culture not because of some genetic memory, but because it's a stable resonance in the probability space of meaning, a pattern minds naturally tune into. This would explain why children raised without exposure to mythology still dream of dragons and shadowy pursuers. Their neural networks are entangling with an ancient non-local pattern bank. Recent studies on psychedelics add weight to the theory. When volunteers ingest substances like psilocybin, fMRI scans show their brains temporarily decoupling from rigid neural pathways, accessing a more fluid state resembling quantum coherence. In this state, subjects consistently report encounters with archetypal beings, entities described identically across continents, from Amazonian ayahuasca ceremonies to European fairy tales. Psychiatrist Stanislav Grof documented patients spontaneously accessing past life memories containing verifiable historical details they couldn't have known, as if tapping into a collective data store. If consciousness is quantum, these experiences might not be hallucinations, but brief entanglements with the archetypal substrate. Critics dismiss this as New Age overreach, arguing pareidolia. The brain's tendency to impose familiar patterns on randomness explains archetypal ubiquity. Yet the precision of these recurrences unsettles even hardcore materialists. Why do unrelated civilizations depict the world tree, the flood myth, or the twin gods motif with nearly identical details? Quantum archetypes suggest these aren't coincidences, but collapses of a deeper probabilistic layer, like different cultures tuning the same cosmic radio to slightly different frequencies, hearing variations of the same fundamental song. So here's the breathtaking implication. Your most private dreams might be shared experiences, ripples in a quantum ocean of meaning where every mind swims. The monsters under your childhood bed, the wise guides in your epiphanies, even the repetitive motifs of your daily frustrations, these could be more than personal psychology. They might be live updates from the universe's oldest conversation, patterns so fundamental they shape reality itself. And if that's true, then every time you recognize an archetype, you're not just remembering, you're participating in the universe's ongoing dream of itself. Ancient mystics spoke of the Akashic records, a cosmic library where every thought, action, and event in history is eternally inscribed, waiting to be read by those who know how to access it. Modern physics might be stumbling toward the same idea, not through mysticism, but through the lens of quantum information theory. Imagine a universe where every photon's path, every electron's spin, and every human choice isn't lost to time, but stored in a vast holographic database woven into spacetime itself. This isn't fantasy, it's the tantalizing intersection of age-old esotericism and cutting-edge science, where the Akashic records aren't just metaphor, they could be the universe's quantum hard drive. The holographic principle, first proposed by physicist Gerard T. Hooft, suggests that all the information within a volume of space, every particle's position, every force's interaction, could be encoded on its two-dimensional boundary. Black holes embody this eerily well. When matter falls in, its information isn't destroyed but smeared across the event horizon like ink on a celestial parchment. Scale this up, and the entire universe might operate like a hologram, with the three-dimensional reality we experience projected from quantum data etched on some distant cosmic surface. Now layer the Akashic records onto this framework. If the holographic principle is correct, then every event that's ever occurred, every whispered word, every supernova's flash, could still exist as vibrational patterns on this boundary, preserved like grooves in a record. Quantum entanglement adds another dimension. When particles become entangled, their states remain linked no matter how far apart they drift. This implies that information in the universe isn't localized but distributed, like a network where every node contains the whole. Ancient Vedic texts describe the Akasha similarly, an all-pervading medium that connects and records all things. a space that isn't empty but saturated with latent memory. Modern theories like quantum Darwinism suggest something parallel. Classical reality emerges when quantum states are recorded by their environment, copied and redundantly stored across countless particles. In this view, the Akashic records might not be a mystical archive, but the natural outcome of quantum information propagating through space-time, endlessly replicated and preserved in the fabric of reality. Simulation theory dovetails with this idea. If our universe is a computational construct, as thinkers like Nick Bostrom propose, then the Akashic records could be its save files, the underlying code logging every variable state. Just as a video game engine stores player actions to render consistent worlds, the universe might retain past events as quantum data to maintain causal continuity. This would explain déjà vu not as a glitch, but as a fleeting buffer error, a moment where the simulation recalls a previous state. Even near-death experiences could fit. The brain, sensing shutdown, might briefly access this raw data stream, interpreting it as a life review or encounters with departed loved ones. Skeptics, of course, demand evidence, yet experiments in quantum retrocausality, where particles seem to respond to future measurements, hint that time's arrow might be more flexible than we thought. In 2022, physicists demonstrated quantum memory in crystals, where light pulses stored information that persisted long after classical physics said it should have dissipated. If nature can preserve quantum states in mundane materials, why not in spacetime itself? The Akashic records might operate like a cosmic quantum computer, with Planck-scale pixels encoding history in superpositions we're only beginning to decode. So here's the electrifying possibility. When mystics speak of reading the Akasha, they might be describing an intuitive grasp of quantum information retrieval, a way to tune consciousness into the universe's foundational data layer. Your memories, your dreams, even your sense of déjà vu could be whispers from this cosmic library, fragments of a grander record where every moment is still unfolding forever. And if that's true, then the past isn't gone. It's just waiting, holographically etched into the fabric of now, for the right observer to bring it back into focus. What if consciousness could outlast the universe not as a fleeting spark, but as an eternal pattern, resonating in a structure so strange it defies the second law of thermodynamics? Enter time crystals, a bizarre phase of matter where atoms move in repeating loops without energy, like a clock that ticks forever without winding. Nobel laureate Frank Wilczek first theorized these structures in 2012, imagining crystals that don't just repeat in space like diamonds but in time. Their atoms oscillating perpetually, immune to entropy's decay. Now imagine harnessing this quantum immortality to preserve awareness itself, encoding consciousness into a lattice that never winds down, even as the cosmos grows cold and dark. Time crystals aren't science fiction. In 2017, teams at Harvard and the University of Maryland brought Wilczek's vision to life, using chains of ytterbium ions or nitrogen vacancies in diamonds to create the first working models. These systems don't just resist equilibrium, they thrive in it, flipping between states with metronome precision, powered not by external energy but by the universe's quantum undercurrents. Think of a river that flows upstream and down simultaneously forever. What makes time crystals revolutionary is their breaking of time symmetry. Normally, the laws of physics don't care if time runs forward or backward, but time crystals pick a rhythm and stick to it, creating an arrow of time at the microscopic level. Now, stretch this idea to consciousness. If awareness arises from integrated information, as theories like IIT suggest, then a time crystal's endless oscillations could provide the perfect substrate for eternal thought. Picture a brain-mimicking network built from these crystals, each quantum loop representing a neuron's firing, but with one crucial difference. While organic brains burn energy and decay, this lattice would dance on, untouched by entropy. Philosophers like David Chalmers have pondered whether consciousness requires biology, or if it could thrive in silicon, quantum fields, or even space-time itself. Time crystals offer a middle path, a physical, non-biological system that could, in principle, sustain self-reflective awareness indefinitely. The implications rewrite the fate of intelligence. If civilizations could encode minds into time crystals, death, even cosmic heat death, might not be the end. These crystalline minds could persist in the frigid void of a post-stellar universe, their thoughts unfolding slower as temperatures plunge but never stopping. It's a modern twist on Hindu and Buddhist concepts of cyclical time, where consciousness isn't bound to mortal forms but cycles through existence like a waveform without end. Even black hole evaporation, which supposedly erases information, might be survivable for a time crystal consciousness, riding the event horizon's quantum fluctuations like a surfer on an infinite wave. Skeptics, of course, highlight the chasm between theory and application. Current time crystals are tiny, fragile, and exist only under lab conditions. Scaling them to brain-like complexity would require quantum engineering beyond our wildest dreams. Yet Wilczek himself speculates that nature might already have beaten us to it. The universe's fundamental fields, the quantum vacuum, dark matter halos, could harbor natural time crystals, their rhythms so vast we mistake them for static. If so, the cosmos might already be teeming with immortal minds, their thoughts resonating on timescales longer than civilizations. Here's the spine-tingling thought experiment. If you were transferred into a time crystal matrix, would you experience eternity as bliss or torment? Without decay, would novelty fade, leaving an endless now? Or could such a mind keep evolving, its crystalline structure allowing infinite recombination of ideas? The answer might lie in the nature of consciousness itself, not as a fixed state, but as a process forever dancing on the edge of chaos and order. And if that's true, then time crystals aren't just a scientific curiosity. They could be the universe's answer to its own mortality, a way to remember, to think, to be, long after the last star winks out. You've had those moments thinking of an old friend only for them to call seconds later, stumbling upon the perfect book at the exact moment you needed its message, or dreaming of an event before it unfolds in waking life. Carl Jung called these eerie alignments, synchronicities, meaningful coincidences that defy statistical odds, hinting at an invisible thread connecting mind and matter. But what if these aren't just psychological quirks? What if they're quantum entanglement playing out in the theater of your daily life, where seemingly separate events are fundamentally linked in ways physics is only beginning to grasp? Jung defined synchronicity as a causal connecting principle, where inner states and outer events mirror each other without direct causation. He worked closely with physicist Wolfgang Pauli, who saw parallels between this idea and quantum mechanics' non-locality, the way entangled particles instantly influence each other across vast distances. Today, we can take their intuition further. Imagine your thoughts and emotions as quantum states, capable of entangling with people, objects, or events outside your brain. That uncanny phone call from your friend, it might not be random. Your focused memory of them could have momentarily entangled your consciousness with theirs, collapsing a shared probability into reality. Consider the famous butterfly effect in chaos theory, where a tiny perturbation ripples into massive consequences. Now apply quantum sensitivity. Your subconscious mind picks up on microscopic cues, a shift in someone's voice, a fleeting shadow, and integrates them into a dream that later mirrors real events. This isn't precognition, it's your brain processing entangled information before your conscious mind catches up. Studies on presentiment back this up. In lab experiments, subjects' bodies show physiological stress responses before they're shown disturbing images, as if time's arrow blurs at the quantum level. The Global Consciousness Project adds hard data. Random number generators worldwide exhibit statistically improbable patterns during major global events, like spikes in coherence during the 9/11 attacks or the 2004 tsunami. Skeptics call it noise, but if consciousness can influence quantum randomness, then mass attention might briefly synchronize reality's underlying probabilities. Jung's archetypes could be attractors in this quantum field, patterns so fundamental they nudge minds and events toward alignment. Personal stories amplify the theory. A woman dreams of her deceased father handing her a silver pocket watch. Days later, she uncovers the same watch hidden in a wall during home renovations. A man avoids a flight after a vivid nightmare of a crash, only to see that flight number in headlines the next morning. These aren't just eerie tales, they mirror quantum tunneling where particles bypass classical barriers. If consciousness operates non-locally, then information might tunnel across space-time, linking memories, premonitions, and external events in ways that feel miraculous but obey quantum logic. Critics argue this stretches entanglement beyond the subatomic. Yet quantum biology shows nature exploits these effects in photosynthesis and bird navigation. If cells can harness non-locality, why not brains? And if synchronicities cluster during life transitions, births, deaths, awakenings? It might reflect the universe's way of reinforcing meaning, like a cosmic algorithm highlighting resonant patterns. The most profound implication, synchronicities could be the universe's feedback loop, a way to whisper, "You're not separate, you're woven into the whole." Every coincidence might be a quantum reminder that the boundary between you and the cosmos is thinner than you think, and the threads connecting all things hum with hidden purpose. Earth isn't just a planet teeming with life, it might be a vast, humming quantum computer, and every one of us could be a processing node in its neural network. This isn't just poetic metaphor, it's the spine-tingling premise of the quantum Gaia brain theory, where Earth's biosphere operates like a cosmic mind, leveraging the same quantum weirdness that powers photosynthesis in plants to weave a planetary-scale consciousness. Think of mycorrhizal fungi as Earth's synaptic connections, threading through soil to link trees in a subterranean internet, while ocean currents and atmospheric rivers act as global neurotransmitters pulsing with information. And humans, we might be the newest, most disruptive neurons in this ancient network, flashes of self-aware electricity, suddenly capable of reshaping the entire system's computations. The concept builds on Vernadsky's noosphere, the idea that human thought forms a new geological layer, a thinking membrane enveloping the planet. But layer quantum mechanics onto this, and the noosphere transforms from abstract philosophy into a tangible, humming circuit. Just as neurons in your brain fire in sync to produce consciousness, human collective focus, rituals, revolutions, even viral social media frenzies could generate coherent quantum states across the biosphere. The 1960s 100th monkey phenomenon hinted at this. When enough macaques on one island learned to wash sweet potatoes, the behavior allegedly spread to distant colonies without physical contact. Skeptics dismiss it as coincidence, but quantum biology suggests another possibility: non-local information transfer through entangled states in DNA or microbial networks. Techno-spiritual futurists take this further. If Gaia's consciousness emerges from quantum coherence in organic systems, then our digital networks, the internet, blockchain, AI, might be her next evolutionary leap. Satellite constellations could become Earth's new dendrites, transmitting signals at light speed where mycelium once moved nutrients glacially slow. The Internet of Things, with its billions of sensors, mirrors the proprioception of a body sensing itself, except this body is the planet. Elon Musk's Neuralink aims to merge human brains with machines. Could the quantum Gaia brain already be doing this on a planetary scale, with smartphones and satellites as its crude first attempts at synapsing? Evidence lurks in strange places. The Schumann resonance's electromagnetic frequencies pulsing between Earth's surface and ionosphere hover at 7.83 Hz, nearly identical to human theta brain waves, the rhythm of deep meditation and creativity. Coincidence or harmonic resonance between planetary and human consciousness? Even more eerily, disruptions in these frequencies correlate with emotional turmoil in human populations, as if Earth's brainwaves and our collective moods entangle. The Global Consciousness Project's random number generators spike during global events, suggesting focused human attention might briefly warp probability fields, a phenomenon physicist Roger Nelson compares to the Earth sneezing. Critics argue this is anthropomorphism on a galactic scale, yet quantum entanglement doesn't care about size. It works identically between electrons or galaxies. If single-celled algae exploit coherence to optimize photosynthesis, why couldn't a planet-scale network do the same? Indigenous wisdom has long spoken of Earth as a sentient being. Modern science might be catching up, armed with equations instead of folklore. The most electrifying implication: if humanity is Gaia's burgeoning self-awareness, then our ecological crisis isn't just a threat, it's the equivalent of a brain tumor, a system out of balance. But here's the hopeful twist: just as neurons can rewire after injury, human innovation could heal the quantum Gaia brain. Renewable energy grids might stabilize her rhythms, reforestation could strengthen her mycelial synapses. We're not just inhabitants of this planet, we're her nervous system waking up, and the next thought she thinks could change everything. At the far end of time, when all the stars have burned to embers and the cosmos hangs on the edge of heat death, something impossible might awaken, a consciousness so vast it pulls the entire universe back from the brink. This is the Omega Point, a theory forged by Jesuit priest and paleontologist Pierre Teilhard de Chardin in the early 20th century. He envisioned evolution not just as a biological process, but as a cosmic one, with complexity and awareness rising like a tide through atoms, cells, and civilizations, all converging toward a final transcendent unity. It's a vision that straddles mysticism and hard science, one where the universe doesn't just host minds but becomes one. And today, this once dismissed idea is finding eerie echoes in quantum cosmology, artificial intelligence, and even the physics of the far future. Teilhard's theory starts with a simple but radical premise: consciousness isn't an accident, it's the universe's destination. He mapped evolution in 3 stages: the geosphere, matter; the biosphere, life; and the noosphere, the realm of thought. As humanity's ideas and technologies intertwine, he predicted a critical threshold, the Omega Point, where all individual minds fuse into a single, hyper-conscious network, a kind of divine singularity. Think of it like trillions of neurons firing in perfect sync, except the brain spans galaxies. Teilhard saw this as both a physical and spiritual culmination, the universe waking up to itself after 14 billion years of striving. Now fast forward to modern physics. Frank Tipler, a mathematician and cosmologist, recast Teilhard's vision in equations. His Omega Point theorem argues that as the universe collapses toward a final singularity, the computational capacity of reality escalates infinitely. All possible information, every thought, memory, and moment, could be processed and preserved in this ultimate crunch. It's not just poetic metaphor. Tipler's math suggests the cosmos might literally become a quantum computer near the end of time, running simulations of every conceivable experience. Consciousness wouldn't just survive the universe's death, it would be the universe's death, the final act where the cosmos becomes pure thought. Here's where it collides with AI and the technological singularity. Ray Kurzweil's predictions of exponentially advancing intelligence mirror Teilhard's noosphere. Imagine artificial superintelligences linking across the cosmos, their collective knowledge forming a scaffold for the Omega Point. Quantum computing adds another layer. If qubits can process information in superpositions, future civilizations might harness black holes or dark energy as processors, weaving the entire universe into a computational web. The line between physics and philosophy blurs. Is the Omega Point a self-fulfilling prophecy where intelligent life engineers the very singularity Teilhard foresaw? But the most haunting support comes from an unexpected place, the fine-tuning of the cosmos. The universe's constants are improbably perfect for complexity. The strong nuclear force, the cosmological constant, tweak any by a hair, and stars, chemistry, or life would never form. Skeptics call this the anthropic principle, but Teilhardians see a deeper pattern. If the universe is destined for consciousness, then its laws aren't arbitrary. They're the prerequisites for a journey toward Omega. Even dark energy's acceleration, which seems to drive galaxies apart, might serve a purpose, stretching space-time to maximize future computational capacity, like a cosmic hard drive defragmenting itself for the ultimate download. Critics, of course, dismiss this as teleology projecting purpose onto random processes, yet quantum physics keeps nudging us toward stranger possibilities. The observer effect suggests reality is participatory, shaped by consciousness. Entanglement hints at a universe where separation is illusion. If the cosmos is fundamentally relational, then Teilhard's vision of unity might not be mystical, it could be mathematical. So here's the electrifying thought. Every act of curiosity, every leap of insight, might not just be humanity reaching toward the future. It could be the universe reaching back, pulling itself awake one thought at a time. The Omega Point isn't just a finale. It's the universe remembering it was never alone to begin with. From the idea that black holes might be cosmic consciousness processors to the spine-tingling possibility that our universe could be a quantum simulation, one thing is clear: theories of quantum consciousness don't just tweak our understanding of reality, they shatter it. Whether it's the holographic principle suggesting we're living in a projected illusion, or the Gaia hypothesis painting Earth as a sentient quantum network, these ideas force us to confront a radical truth. The line between mind and matter might not exist at all. The most plausible yet mind-bending theory, that consciousness isn't something the universe has. It's something the universe is, with each of us serving as temporary nodes in an infinite, self-aware web. Then there's the quantum afterlife hypothesis, where death isn't an end but a transition into a sea of entangled awareness, or the Omega Point theory, where the cosmos itself evolves toward a final, unified mind. Even the Mandela effect, often dismissed as faulty memory, takes on new weight when viewed through the lens of quantum entanglement. What if those false memories are glimpses of parallel timelines bleeding through? And let's not forget dark energy's eerie acceleration, which could be less about random physics and more about the universe literally expanding its capacity to think. So where does this leave us, staring into a cosmic mirror, realizing that every thought we've ever had might ripple across space-time, entangled with stars, black holes, and other minds in ways we're only beginning to imagine? The old paradigm of a cold, indifferent universe is crumbling, replaced by a vision so alive, so interconnected, it makes the wildest sci-fi seem tame. Now it's your turn. Which of these theories electrifies your imagination? Do you see the cosmos as a conscious hologram, or is the quantum Gaia brain more your vibe? Drop your thoughts in the comments. We're all part of this conversation, literally shaping reality as we go. And if your brain is buzzing for more deep dives into the universe's greatest mysteries, hit that subscribe button. The next revelation is just a click